Okay, I think we can start. So
Yes.
let me formally say a very good morning to everyone here in Sri Lanka and a very good evening again to you, dear James. I warmly and excitedly welcome first our distinguished speaker, Dr. James Tanton, uh, the co-founder of MetaHub, Dr. Shelton Pereira, the Director of Education in Mathematics of the Ministry of Education, Mrs. P.P. Niroshi, the Deputy Director of Education in the Mathematics branch of the Ministry of Education, Mrs. K.G.L. Nirisha, and all the participants who have joined to this first ever international webinar organized by the MetaHub to our own Sri Lankan mathematics teachers. I would like to first ask everyone to mute your microphones because we still hear a bit of noise from some of your, I think some of you still have your microphones on. Let me just, I think I can off it from my end. Okay, should be good now. Yeah, so let me tell you a little bit about MetaHub. MetaHub, Mathematics Education Teacher Awareness Hub, is the first ever web-based platform that connects mathematics teachers of Sri Lanka with the field of mathematics education. It was launched in November last year, and it is a collaboration between the Ministry of Education and the Science for Technology Department of the University of Sri Jawadarnapura. So we are very excited to have you all here, our dear own teachers. And from our pre-registration, we know that though many of you in our audience today are mathematics teachers from grade 6 and above, just as we intended, we also have a couple of university academics, various educational officers, and also individuals who are joining with us for the mere experience of joyful mathematics. Okay, so then let me now introduce to you our distinguished speaker. But before that, let me again remind you to please keep your microphones off, switched off, because if there is noise in the background where you are, we can hear all that and it disturbs. So please keep the microphone off unless you are interacting with the speaker. Yeah, so Dr. James Tanton is a mathematician as well as a mathematics educator who was born and raised in Australia, now living in Phoenix, USA. He's right now in Florida. He earned his PhD in mathematics from Princeton University. He has received many awards and honors, such as Princeton University Engineering Council Teacher Award for teaching excellence. He is the author of over 10 books on mathematics, curriculum, and education. Dr. James Tanton is a mathematician at large for the Mathematical Association of America. He is also the co-founder of Beagle Learning, co-founder of the Global Math Project that has reached over 4 million students and teachers from over 160 different countries and territories. He believes that mathematics really is accessible to all, and he's committed to sharing the delight and the beauty of mathematics. Dr. James Tanton, we are honored to have you here, and it is my absolute pleasure now to invite you to deliver your talk. Over to you.
Oh my goodness, what an honor indeed. Thank you very much for having me. Such a pleasure and truly an honor to be the inaugural speaker for you. This is such a joy, such a delight. And let me just make one little correction. We've now reached over 7.8 million students and teachers all across the globe.
That's the latest
on mathematics. I know. So the numbers keep going up and up and up. It's just wonderful. So my passion has been mathematics all my life. Well, almost all my life. As you heard, I grew up in Australia and I went through a very traditional school system, which wasn't joyful. I did not actually like mathematics when I was a school student. It wasn't until I went to university that I fell in love with mathematics, and I found out that math was all about the why questions. Why do things work the way they do? And the what else questions and the what if questions, which my young mind as a kid was pining for. I could do all the formulas, I could do all the calculations, but I didn't find it joyful until I went to university and found let's think deeply about mathematics. And that stirred in me a passion to let's bring that joyful mathematics to one and all. Even school mathematics. School mathematics can be a portal to wonder and joy. And I know you're each doing fabulous, wonderful work with your students to bring that human connection, to bring that human joy to students all across beautiful Sri Lanka. But let me share with you tonight just an example of the sort of thing I really, really found a passion for, which is take a standard topic in the curriculum and show that it can actually be transformed into something meaningful and teaching thinking, teaching how to be a citizen of the world, teaching how to be an empowered citizen of the world. I don't expect all my students to love mathematics, to fall in love with mathematics, or even to become a mathematician. That's okay. But I'd love every student to see that there is something to fall in love with and how thinking about mathematics can empower you to think about life and make success in life. So tonight I thought I'd talk about a very standard high school topic, quadratics. Who doesn't love quadratics? So let me just check that my sharing my screen is going to work. We checked it earlier, but things can always go wrong last minute. How's this? Are we seeing on a piece of paper the word quadratics?
Yes, we are.
Yes.
And you're seeing my hands on top of the word quadratics. We are good and golden. So as I go along today, please interrupt me anytime. I've got my chat window open so I can see chat messages that come in. That's an easy way to ask a question. Or it's actually okay if you just interrupt me by turning off your microphone and speaking. Now we have 340 people, so that might be tricky, so maybe the chat's the way to go. But if everything I say is confusing, let's just feel free to interrupt me. This is not really a talk, it's not really a lecture, it's really an experience of let's engage in a conversation about mathematics. And the conversation is going to be this, quadratics. And let's be very, very clear. Oh, someone's drawing on the screen already. Fabulous. Okay, let's be very, very clear. Quadratics, what is a quadratic? So it's really something from algebra. So it's a special type of algebraic expression. And they're usually ones written in the form some number times a variable x squared, plus another number times the variable x all by itself, plus another number c. Ax squared plus bx plus c. So that's a quadratic expression. If I write an equal sign and write equals 0, now it's a quadratic equation. Or if I say, no, let the function be this, then it'll be a quadratic function. But there it is, there's a quadratic, anything of this form. And here's the thing that I love about mathematics. I have a question already. Now, I know English is not your first language necessarily, but what does the prefix quad mean in English? What does quad mean? Can you type in the chat what quad means in English? What does quad mean? The prefix quad mean? Yes. Quad means 4. It means 4, which is really interesting. What has this expression got to do with the number 4? Where's the number 4 in that expression? Why that name? And you might say, okay, well, there are 3 terms. Okay, that's not 4. Maybe there are 4 symbols, A, B, C, and X, but that seems a bit weird because there's actually a 5th symbol, 2, as well. What's really going on? And in fact, if you think about this, this is actually a curious question, because I will look at all sorts of expressions. Let me just show you this. Here are all sorts of horrible looking expressions in mathematics. AX plus B, we call that linear, a linear expression. And that name actually makes sense, because if you do graph equations of the form y equals ax plus b, yes, you will get a straight line graph. So that's why we call them linear. Then we got this one, which we call quadratic. Quadratic, there's the 4, quadratic. But then it gets strange. If I do an expression like this one, we call that a cubic equation. And cubic makes sense because x cubed is there. If I go to x to the 4th, we call an equation like this a quartic equation. And that's the confusing thing, because there's 4 again. Quart also means 4. And then we call this one a quintic equation. Quintic means 5. Quint means 5. And we call this, I know what we call this one. People don't usually go up to the 6th degree. The 6th degree would be sextic equation or something, and then a septic equation or something. It's weird. We go linear, 4, 3, 4, 5, 6, 7. That is very strange to call that 4. So here's the first mystery. Why are they even called quadratic equations? And the clue is right there, right there. That's a square. We call that x squared. And these equations became known as the equations that could be solved by thinking about squares. And the Latin word for square is quadrus. So these became equations called the quadrus equations, equations that could be solved by thinking about squares. And most students do not realize it's literally about playing with squares. You might even teach in the curriculum this thing called completing the square. We are literally drawing a picture of a square and completing the picture. These are the equations that could be solved by the square method. Hence, they became known as the quadrus equations, hence the quadratic equations. You go linear, 4, 3, 4, 5, 6, 7. You still like to associate 4 with these for the word square. So here's what I love about playing with the algebra of quadratics. So I'll just play with the focus on algebra this morning. And I'm going to ask you a question. It's really a course about symmetry, the power of teaching symmetry. And I'm going to ask you this question. I'm going to draw you a rectangle. There is my beautiful rectangle. And I'm going to tell you the area is 36 square units. There's a rectangle. Oh, my camera's being a bit naughty. Let's try this. There we go. There we go. I think that's better. I think it likes black markers better. So let me put some extra things on my screen. All right. So there's a rectangle of area 36. Here's my question to you. What can you say about that rectangle? Can you tell me anything about that rectangle of area 36? And the chat is very silent because the thing is, you can't say much about the rectangle. I mean, you might say maybe it's 4 by 9 rectangle. That would give an area of 36. Or maybe it's a 3 by 12 rectangle. That would be an area of 36. You just don't know. Maybe it's a 4.5 by 8 rectangle. Maybe it goes into fractions. You basically know nothing. You know nothing about that rectangle, except it's a rectangle and it has area 36. Or it could be, you're right, or it could be 36 by 1. You just don't know. You're just guessing. We have to guess. We don't know anything about the rectangle. But if I said, oh, no, I'm sorry, I meant to say it's symmetrical. It's the most symmetrical rectangle you possibly have. If I add that word symmetrical, I bet you suddenly know everything about that rectangle of area 36. Because if it's symmetrical, you know, oh, it must be a square of area 36. At a square of area 36, you know everything. It must be a 6 by 6 square. As soon as you have said the word symmetrical, then suddenly all of this uncertainty actually then must be certain, reduces to certainty. Because the most symmetrical rectangle you can have, I know everything about that rectangle. It's a square of side lengths of 6. So the message we have here is that symmetry is our friend. All right, symmetry is our friend, which is beautiful. That's really the message of tonight. And what I really want to teach students is the power of using your logical thinking, your brain, and your common sense, even in an algebra class. For example, I'm now going to go through the algebra of solving quadratic equations. And I'm going to start with the most obvious ones, very easy ones to begin with, about using symmetry as our friend. In fact, I'm going to call this a level 1 problem. Here's my level 1 problem in solving quadratics. The question is, x squared equals 25. Can we solve that equation? And you might feel like, why did I sign up for this? Because that's a very obvious equation, James. What are you doing? You're insulting my intelligence. But let's think about it. Let's think about it. I just said x squared. So it's the situation I said before. It's literally a picture of a square. And I'm telling you, its side length x by x makes an area of 25. And you know what the answer has to be. X has to be 5. X must be 5 is a solution to that equation. Great. Now, If I think solely in terms of geometry, this is the only answer. 5 units by 5 units makes an area of 25. But if I open up my mind, I could say, well, in arithmetic, there's actually a second answer. I can't have a side length of -5, but in arithmetic, I know that -5 times -5 is also 25. So yes, in geometry, there's one answer, but in arithmetic, there's 2 answers. So let's be powerful and do all the possible answers we can, even though I can't draw a picture like this, -5 times -5 having an area of 25. That makes no sense in a geometry. However, it still makes sense in arithmetic. So that's a little bit naughty there, but there's the full answers if I open my brain to do geometry and slightly beyond geometry. Okay, so level 1 questions are fine. I mean, for example, what's the answer to x squared equals 100? Can you just quickly write that in the chat for me? Exactly. Again, if I've got a square area of 100, must be because the side length is 10, by literally thinking geometry. Or if I open up my mind and say, okay, I could also do arithmetic, or x could be -10. It could be the positive version or the negative version, and my camera is being naughty again. All right, let's focus on this. There we go. Great. Here's something that confuses students. For some reason, the curriculum world is obsessed with the letter x. Is this equation okay to solve? W squared equals 4. Does it have to be x, or could it be a different symbol? And I know what everyone's thinking. It doesn't have to be x every time. The whole world's obsessed with letter x, which you're right. Got a square of area 4. W could be 2. Or 2 or could be -2. All right. Doesn't have to be x at all. Brilliant. That's confusing the students because we often obsess with letter x over and over again. It's good to use different letters every now and then. Sometimes quadratics could be not so friendly. What about x squared equals 5? Are we okay with that one? That level 1 question? Good luck typing this one in the chat. This is going to be hard to type into the chat. In terms of geometry, I'm asking you, what's the side length of a square of area 5? And you're right, we call that the square root of 5. In fact, we even use the language square root. The root feature of a square of area 5 is square root of 5. And you're right, if I'm thinking geometry, there's only one answer. If I open my mind to all arithmetic, there's a second answer, the positive and negative versions. You've so got this, grand and good. Level 1 is not a problem. So let's go upper level. Let's make this like a game, like a video game. You've done level 1, you've mastered level 1. Let's now go to level 2 quadratics. So exciting. How about this one? X plus 2 squared equals 36. Okay. All right. So now it's a little more complicated. I'm going to say, okay, what's going on here? But if you heard just what I just said, I said x plus 2 squared is 36. Something squared is 36. Something squared is 36. So my x plus 2 is either 6, like you're telling me in the chat, or the negative version, -6. Something squared is 36. Common sense tells me I've either got 6 or -6. X plus 2 is that. Let's subtract 2 from everything. And yes, you're right. X is either 4 or subtract 2, -8. So actually, there's 2 answers there. Beautiful. So something squared is 36. My something better be 6 or -6. And I'm going to fix it up to get x all by itself and see that x is 4 or -8. Beautiful. Okay, let's do another one. X minus 3 squared is 25. Oops, 25. My handwriting, forgive my handwriting. Something squared is 25. Logic then tells me yeah. Something squared is 25, so my something better be 5 or -5. That's beautiful. Okay, and then let me add 3 throughout. X must be 8 or -2. Beautiful. You've got the hang of this. By the way, a lot of people do this, and I don't encourage students to do it. They'll say, oh, x minus 3 is plus or minus 5. Do you see what the temptation to do next is? X must be plus or minus 8. And that's not correct. This is why I keep writing the word or. If you keep it separate, it's very clear I'm adding 3 to 5, or I'm adding 3 to -5, in which case I get x equals 8 or -2. I say don't be fast. Fast can get you into trouble. Take the extra 1 second to write the word or, and everything will be clear. Okay, this is gorgeous. Let's just do one more, and level 2, and I don't know, I'll make it something like x minus 3 squared. Now let's make it x plus 3 squared equals 100. Let's try that one. On your ownsies, can you solve this level 1 quadratic for me? You might even be able to do it in your head. Absolutely beautiful. The power of a square. If I know something is a square, I know that something better be 10 or -10. And a little bit of fixing it up. There's x must be 7 or -13. You've so got it. Beautiful. Level 1 done. Level 2 done. We're golden. Let's now do level 3. Level 3 of quadratics. It's very exciting. I'm glad you signed up for this, because here goes. X squared plus 6x plus 9 equals 100. Welcome to level 3. And this is where we have a shock. This suddenly looks very, very different. And we're having a little panicky moment. At least I'm having a little panicky moment. So people forget that we are all humans and we have emotions. And my emotion right now is I'm scared. I'm scared. And I say, okay, this doesn't look like anything we're doing earlier on. It was all about squares earlier on. And this has got, okay, it's got a square, but it's got extra stuff that gets me very nervous. What can we do here? And some people are on to me in the chat. I bet you know what the answer is. Well, let's think like a student. So squares have been my friend. Squares have been my friend. Symmetry's been my friend. I could at least draw a square for that part. So I could draw a perfectly nice square right there, x squared, which comes from x times x. That's great. But the trouble with this problem, it's got extra stuff. It's got an extra piece of a 6x and it's got a 9. So the question is, how can I add a piece that represents 6x? And you look at what's on the page right now and say, okay, well, there's x by x, and I want 6 by x. Maybe I can add a piece that's 6 units long like this. If it's 6 units long, I'll get a piece that's 6 by x. That gives me 6x. Great, great. But then I look at this and say, ooh, not symmetrical. That makes me very nervous. I'm very nervous. Symmetry is my friend, and I've just done something that's not symmetrical. So now we have a challenge. Is there another way I can get a piece that represents 6x in a way that keeps things symmetrical? And you think about this for a while, and you go for a little walk, and eventually a student will suggest, do your x squared piece, that's fine, x by x. But let's actually make this area of 6x symmetrical around that square. Sorry, my camera's being a bit of a pain, a bit naughty. Oh, there we go. All right. Let's put a piece of area 3x there, 3x, and an area of 3x there, 3x. There is 6x. X times something is 3x. That must be a 3. Something times x makes 3x. That must be a 3. Great. There's the x squared piece. There's 6x from 3x and 3x. And now you can see why the term completing the square is called completing the square. Because it seems irresistible to want to draw that extra piece there, which would be 3 by 3, which makes 9. There's the 9. We lucked out. That's beautiful. I see x squared plus 6x plus 9 is really a square. It's really a square. In fact, it's a square that's x plus 3 by x plus 3. This problem is really level 2 in disguise. It's x plus 3 as a square equals 100. And in fact, you were so right. That's actually the question I did moments ago. The answer is 7 or -13. Actually the same. So something squared is 10. My something must be, is 100. My something must be 10 or -10. Therefore, x all by itself must be 7 or -13. I literally drew a symmetrical picture for myself. It wasn't quite complete to make a square, I literally completed the square. That's what people mean by completing the square. And that's level 2. Level 2 is about turning level 3 problems back into level 2 problems. This is great. So, for example, x squared plus 4x plus 4 equals 49. And my brain says, okay, let's make this a square, because squares are my friends. I like squares. Symmetry is wonderful. Symmetry is powerful. So I say, okay, I know there's going to be an x squared piece. In fact, I'm going to draw a whole square right now. I know there's going to be an x squared piece. X squared that comes from x times x. Got that. Now I want 4x, but I want to keep things symmetrical. So we make it 2 pieces, a 2x and a 2x. That keeps it nice and symmetrical. And I ask myself, what times x makes 2x? That'll be a 2. What times x makes 2x? That'll be a 2. And I can see, oh, the remaining piece must be 2 times 2, which is 4, which is exactly what I want. I've got all the pieces. It's all the pieces are right there. And I can see this is really now that this question, x plus 2 as a square is 49. It's back to being level 2. It was level 2 in disguise. That is beautiful. And I can now solve it. Something squared is 49. So my something must be 7 or negative 7. Great. Take the extra 1 second, write the word or, because now I can see what to do. Subtract 2 from everything. Must be 5 or negative 9. This is just lovely. Gotta love it. Literally draw a picture of a square and use your common sense thereafter. Let's teach the world how to use their common sense. All right, on your ownsies, try this one with the square method. X squared plus 20x plus 100 equals 64. Try drawing yourself a beautiful picture to make this a common sense question to figure out. If we can see it. There we go. How am I doing? I'm just following my nose. X squared piece, that really is a square. 20x, keep it symmetrical, split it to 10x and 10x. Try to make the rest of the square. I want side of 10, side of 10. This must be a side of 100. Beautiful, beautiful, beautiful area of 100. I've got it. This is really a level 2 problem in disguise. X plus 10 squared is 64. And now we're set. Something squared is 64. My something is either 8 or negative 8, which means x must be negative 2 or negative 18. Beautiful, beautiful, beautiful. The power of using common sense. All right, we are feeling good. Life is grand and good. One thing I love about mathematics is that it really teaches life lessons. We've got the hang of this. We're feeling good. Now here comes Houston. We have a problem moment. Here's a Houston, we have a problem moment. Welcome to level 4. Because now it's going to be a spanner in the works or a wrench in the works. I don't know what people say in your part of the world. So let's see. Let's try x squared plus 8x plus 15 equals 80. Try that one and see how it feels. Try that one on your own. All right, people are getting the answers, but I'm having a panicky moment myself right now. I've gotten this far. I've got an x squared piece, great. I've got 8x, great. That's going to be 4x and 4x, which means the side here must be x times 4 makes 4x. 4 times x makes 4x, great. Which means the number I want here is 16, 4 times 4. And I'm panicking because I don't have 16. In fact, it makes me want to cry. I'm getting very nervous right now. We've got a mismatch. And I'll say, oh no, what am I going to do? What can I possibly do? Because here is a beautiful moment for students. I really want this to be a 16. Life would be so much easier if that really was a 16. So here's the question. If there's something in life you want, my advice is make it happen and deal with the consequences. For example, if I want 16, I can make that happen by adding 1. That would make it 16. But there's a consequence. I can't just add 1 to the left. If I do that, I better keep it balanced and add 1 to the right as well. So let me rewrite this as x squared plus 8x plus 16 equals 81. And suddenly, if I do that, sorry, my camera's being not well behaved tonight. And whereas, oh, that's exactly what I wanted. X squared plus 8x plus 16 is really x plus 4 as a square in disguise. And that equals 81. And now I'm back to level 2. Life is good. Something squared is 81. So my something is 9 or negative 9. And let's subtract 4. X is either 5 or negative 13, which is what people were saying in the chat. You guys so on top of it. But what I love about that, this now gives a moment for a life skill. If there's something in life you want, make it happen and deal with the consequences. So if there's a problem, you have the agency, the power to do something about it. What a great thing that math teaches. So let's try this one. On your own, please solve for me x squared minus 6x plus 11 equals 27. Try it with the box method. Try drawing a beautiful square, and if there are any mismatches, I advise you, deal with it. Make what you want happen actually happen. Give it a try. Okay, people writing in the chat, I don't actually know the answer. I actually haven't done it myself. I just made this up on the spot. Maybe it's 2 and negative 8. Maybe it's 8. We'll find out. Well, lots of people saying 8 and negative 2 now. Let's find out. You're right. So I've got negative 6x. I want to split that evenly, which means this side needs to be negative 3. This side needs to be negative 3. I know that doesn't make sense in geometry, but in algebra, in arithmetic, that's still fine. Negative 3 times negative 3 is 9. I want a piece of area 9. Trouble is I've got 11. Uh-oh. Houston, we have a problem. We have a mismatch. But if there's something in life you want, make it happen. If I want 9, make it happen. Let me subtract 2, which means I better subtract 2 over there as well. Let me rewrite this as x squared minus 6x plus 9 equals 25. And then suddenly life is good. That's exactly what I've got. That's x minus 3 as a square is 25. Grand. X minus 3, my something must be 5 or negative 5. X must be 8 or negative 2. Great, great, great. You are so on top of it. This is why I love being a math teacher right now. We had a little life moment. I know it's solving quadratics, but actually I'm really trying to teach kids, you are in control. You can make stuff happen to make your life easier. This is beautiful, grand, and good. I think you are ready now for the next level. I think it's level 5. All right, let's do a level 5 quadratics. Don't worry, there's only 17 levels for tonight, for this morning. No, I'm kidding. There aren't many levels. We're almost done. This is all of quadratics, almost done. So level 5. It's going to be another problem. And I wonder if you can tell me what the problem for this one's going to be. X squared plus 3x plus 1 equals 5. What is the problem with this one? What's the problem? Symmetry, you're right. Symmetry is going to be a little bit harder here. And what makes the symmetry harder this time? Try doing my symmetry. X squared is x times x. Yep, that's good. Yes, 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 yes. This being an odd number is awkward, Odd. We could go into fractions, do 1.5x and 1.5x, and do 1.5 and 1.5. But what's my emotional reaction to that? It's this. Ick. That's icky. Who wants to do that? That seems hard. I bet you could do it. I bet you could make it work. In fact, people are telling me the answer is either 1 or -4. I don't know what the answer is. I haven't actually done the problem myself yet. But that seems hard. This odd number here seems to make us go into fraction land and make the work so much harder. So I'm a mathematician. I don't like hard work. In fact, I will work very hard to avoid doing hard work. So here's my question. Let's step back. What could I do to fix this up? If I don't like an odd number there, what can I do to make it an even number? Do you have any thoughts on what I could do to make it an even number? I could add an odd. Oh, if I add an odd number to it, if I add an x to it, if I do it on the left, I better do it to the right as well. Okay, I'll have x squared plus 4x plus 1 equals 5 plus x. I have x's on both sides. That seems really hard to me. That seems even harder. What do I do with 5 plus x? Oh, someone in the chat says multiply by 2. Oh, okay, let's just double everything. I like that. Let's make the equation 2x squared plus 6x plus 2 equals 10. That's okay. That's good. That's giving me an even number in the middle. I love it. Okay, let's do it. Draw me a square for that one. And then you realize, uh-oh, we have another problem. 2x squareds, and we want to keep it symmetrical. I mean, I could do x and 2x, but I just ruined my square. I could do the square root of 2 and the square root of 2, root 2x and root 2x to get 2x squared. But if I didn't like fractions, I don't think I'm going to like square roots. I think it's going to be even harder still. So here's the thing. That was a brilliant move to try to double everything. But someone in the chat just says something that other students will eventually say. I make this a problem for students. In fact, I make it the homework when I do this with kids. Your job tonight is try to think of another idea that will help us out here. Because that's what we do, think of another idea. And people suggest, well, multiplying by 2 was great. It gave us an even number, but it made it very awkward at the front here. People are suggesting in the chat, multiply by 4 instead. So let me rewrite the question. It's x squared plus 3x plus 1 equals 5. There's the question. People are suggesting, go crazy and multiply through by 4. This is going to make the numbers even bigger. 4x squared plus 12x plus 4 equals 20. Does that really help? That's what people are saying, multiply by 4. Is it actually helping? Let's find out. 4x squared piece, there it is. That comes from 2x and 2x. Great, 4 is a good choice. Nice whole numbers. That's done. Now, 12x, let's split that in half. 6x and 6x. Okay, that piece is done. This is looking good. Now, what's going on here? Something times 2x makes 6x. I guess that's going to be a 3. Something times 2 makes 6x. That's going to be a 3. That's great. All right, 3 and 3. Oh, which means the next piece I want is a 9. All right, I want a 9 there. 3 times 3. Oh, bother. I don't have a 9. This problem won't give up. I've got a 4 instead. What can I possibly do? Well, there's something in life you want. Make it happen. Add 5. Add 5. So rewrite this as 4x squared plus 12x plus 9 equals 25, which seems crazy because I made the numbers so much bigger, but I like that. I like what I'm seeing right there. That's exactly all the pieces in my square. It's really saying a 2x plus 3 as a square is 25. And now I'm back to level 2. Beautiful, beautiful, beautiful. Something squared is 25, so my something must be 5 or negative 5. Let's subtract 3 out of everything. That's 2 or negative 8. Divide everything by 2. X is either 1 or negative 4, which I think were the answers in the chat. Yes, you guys were faster than me, way faster than me. But what's actually more interesting is not those answers. It's the process I had to go through and the struggle I had to get there to think my way through how do I make life easy for myself. And I love that. If you don't like an odd number in the middle, try something. Try doubling it. Try adding an X. Think about it. And it takes a while to think about multiplying by 4 is beautiful. That is beautiful. Okay, on your own Z's, try this one completely on your own. X squared minus 5x plus 6 equals 2. If you don't want to work with fractions, I might suggest you multiply through by 4. Give it a try and see if it works out. Just a little practice on your own Z's. People are much faster than me writing answers in the chat. I don't actually know what the answers are. Just made up the problem. I don't know what we get. We'll find out. I think I want a 25 there, not a 24. Bother. I'm stuck again. Except I'm not. Something in life you want, make it happen. Let's add one. Beautiful. So is that 1 and 4? Or was it negative 1 and negative 4? Or was it 4 and negative 1? Or was it 1 and negative 4? Which one is it? Going to check this late night. Okay. X, all right. X is 4 or 1. Beautiful, beautiful, beautiful. Whoops. Page. Okay, you've so got it. This is gorgeous. All right. You guys are just so on the ball here. I think you're ready for level 6. This is the final level. This is the one that has every problem that can possibly go wrong. Everything that can possibly go wrong will go wrong with this example. But you are so ready for it, if my camera's going to behave. I would now like to do 3x squared plus 5x plus 1 equals 9. This has everything that can go wrong is going to go wrong for you. And what's different about this one? What's the difference about this question? And the issue is that I've now put a number in front of the x squared as well. Every example I've done so far, we keep it as a simple x squared. Now you've got a number in front of the x squared. What are you going to do about that one? Oh, someone's searching multiplied by 12. That's crazy. You're right. It has a problem because if I just do 3x squared, I'm going back into square root land. That seems hard to me. I don't want to do that. I don't like the number 3. The 3 is a very awkward number. So how can I fix up that problem first? Yeah, if I multiply by 3, I like that. That will actually make this a nice perfect square. Let's multiply 3 by 3. That makes it 9x squared. That's going to be much nicer. This now is 15x plus 3 equals 27. All right, that's much nicer. That's great. Love it, love it, love it. So I'll have 9x squared. That's 3x and 3x. Love it. Good. That solved that issue. But now I think we have another issue. Oh, bother, it's odd. That's odd. Oh, okay, what should I do now to fix up that issue? Yeah, I think I know you're thinking it. The way I deal with odd is to multiply by 4, which means someone in the chat was very clever. They said, if you're going to multiply by 3 and you're later going to multiply by 4, you might as well multiply by 12 to begin with. So someone saw that right away. They're much smarter than me. All right, I love it. Okay, so I'm going to take this equation and multiply by 4, which seems insane because the number's going to get really, really big. I'm now going to do 36x squareds plus 60x's plus 12 equals 27 times 4. Oh, that's hard. 27 times 4 is like 108 or something. 108. James, what are you doing? You just made the problem with ridiculously large numbers. Surely that's harder. Well, the thing is, no, I think it's made our lives easier. So I draw the box method. Just don't do anything hard. My brain is too small to do hard things. 36x squared, that's still a perfect square. That's lovely. That's 6x and 6x. I love it. 60x split into 2 pieces. 30x, 30x. Oh, I love that. That's really nice as well. That's working. Something times 6x makes 30x. I guess it's going to be 5 6x's make 30x. And 5 6x's make 30x's. That's great. Which means the missing number I want is actually 5 times 5 is 25. Oh, a problem again. I don't have 25. But let's make it happen. Let's add 13. That will get me to 25. I'll do it on the left. I better do it on the right as well. So now my puzzle is really 36x squareds plus 60 x's plus 25 is, oh, that's a hard one, 121. There we go. And yes, you're right. 6x plus 5, that's what my square is. It's really a 6x plus 5 square in disguise is 121. It's a level 2 puzzle back again. And I can keep going. That's going to be 11 or negative 11. I actually don't really care what the answers are. Apparently the answers are 1 and negative 8/3. Okay, great. The answers are 1 and negative 8/3. That's the boring part. The actual numbers don't matter. But what was very interesting to me was this process that I just gave you a very tricky problem, had 3 issues, and you just glided your way straight through it. That is what really teaching quadratics is about, the power of symmetry, power of using common sense and dealing with problems and trying to find agency to do something about it. And yes, the answer happens to be 1 and negative 8/3. Great, great, great. All right, just to practice that on you completely on your own, Z's, I desperately need to know right now some solutions to 7x squared, take away x plus 1 equals 9. Can you do that one completely on your own and deal with every problem that comes your way? Just for practice, draw me a box method, the quadris method for solving this equation. And I don't think I'm going to like the 7. I think this is my first issue. Don't like 7. And I'll do it silently on the piece of paper as well, so you can look up and watch me anytime. Let's see if I get it right. I'm probably going to make arithmetic mistakes. Uh-oh. Uh-oh. Did that correctly? I think I did. There we go. Page. This seems crazy, James. What are you doing, James? These numbers are ridiculous. Oh, do I like 196? Is 196 nice here? And actually, here's a lovely moment. I don't know in my head if 196 is a perfect square, but if I think about it, I did 7 times 7 times 2 times 2. I actually did 14 times 14. I bet it's 14x and 14x. Bet it is. That's great. I didn't ruin my perfect square. Negative 14x and negative 14x. So I've got that piece done and that piece done. Which means I want a negative 1 there and a negative 1 there. Means I want a positive 1 there, which is annoying because I don't have positive 1. So let's subtract 27. Subtract 27. This is insane. James, what are you doing? So this is really, the problem is really in disguise. 196x squared minus 28x's plus 1 equals, arithmetic. That must be 225. This is grand. It's really a level 1 problem. 14x minus 1 squared is 225. I have a feeling 225 is 15 squared, and off we go. I bet we can now do this. It's really back to being an early level quadratic. So the answer is actually not interesting. Once I'm there, I know exactly what to do. I don't want to do it. But okay, apparently the answers are -1 and 8/7. I so believe you because you guys are much faster and cleverer than me. This is beautiful. This is beautiful. This is the quadris method, the square method, hence the name quadratics. People realized early in the history of human mathematics that these can be solved by thinking about squares. I think the Babylonians 4,000 years ago were doing this in the region of the Middle East. All right, just in case you're wondering, I have been doing the quadratic formula with you. You guys might be wondering, James, what you're doing is really weird because usually the first step is never have a number on the side. You should always make this equal to 0. So most people say, James, the first thing you should do is make 7x squared minus x and then subtract 9 minus 8 equals 0. Always make it equal to 0. That is very strange. I didn't do that because I knew I was going to keep changing these numbers. So why bother changing it first if I'm only going to change it later? So I didn't bother changing anything just to make my life easier. However, you're right. In school books, they always say, make the equation something times x squared plus something times x plus something equals 0. So what I'm going to do now to show you that I'm not actually completely loopy, even though it's now 12:30 in the morning for me, there's madness to my reason. There's reason to my madness here. Sorry, I got it backwards. I have actually been doing the quadratic formula all along, though it doesn't look like it. And I'm going to show you, set my cameras at all times when it's misbehaving. It's the wrong time to misbehave. I'm going to show you this is really the quadratic formula in disguise. So let me do the box method on this. I'm going to do exactly the method we've been doing all along. The first thing is, I'm nervous about that a. If that's not a perfect square, I'm in trouble. At least I don't want to deal with square roots. The first thing we do is we multiply through by a. So rewrite this as a squared x squared plus abx plus ac equals 0. All right, that's the first thing we did. Great. Next thing we did, I was a little bit nervous about this number here. If it's odd, I'm in trouble. So let me cover myself. Let me multiply everything through by 4 and make sure that middle term is not odd. So now we get 4a squared x squared plus 4abx plus 4ac equals 4 times 0. So let me play with this equation instead. And it should be friendly because I got a nice perfect square at the front. I've got a nice even number in the middle. So let me draw the box method on this. Let's see. I have to fit on the page. This one's going to be big and messy. So watch out. It's going to be big and messy. All right, here goes. 4a squared x squared. I'm just copying my method. Where does that come from? With a nice symmetrical piece, that'll be what, 2ax times 2ax. Did I get that correct? I think I did. All right. So this piece is done. All right, this middle piece, let's split into 2 symmetrical pieces. Let's make it, instead of 4abx, let's do a 2abx, a 2abx, and a 2abx. Great. That piece is now done. All right, now I have to think my way through here. Something times 2ax gives me 2abx. I guess that's a b. I think that's right. 2 times a times b times x. Yes. And again, b times 2ax would be 2abx. Great. Got that done. which means the piece I want here is b times b is b squared. And I say, uh-oh, James, we have a mismatch. You don't want 4ac, you want b squared. All right, the way to fix that up is get the 4ac out. Let's subtract 4ac from both sides. They'll get that out the way. And let me add b squared to both sides. Add b squared. So now my equation is, I write it all out. This is looking very messy, but I'm doing exactly the work I did before. That just looks scary, but intellectually it's the same problem. Plus 4abx plus b squared equals a b squared take away 4ac, b squared minus 4ac. And I bet your brains are saying, b squared minus 4ac, that sounds familiar. All right. Now, the horror I have right now on the page looks really scary. That looks really, really scary. But the thing is, that's exactly what's inside my square. 4a squared x squared, 4abx, and a b squared. I recognize this left side is just this as a square. It's 2ax plus b as a square as the answer b squared minus 4ac. So there's my level 2 problem. All right, so I've now turned it into level 2. Just the algebra makes it look very scary, but let me now keep going with level 2 work. Let's actually solve that. This is going to take me a little while, but I'm going to do it because you are my audience tonight. So that means 2ax plus b. My something squared is, whoops, something squared is that answer, which means my something is either the square root of b squared minus 4ac, or it's the negative version of the square root of b squared minus 4ac. All right. Let me take away a b from both sides. So that tells me 2ax is either square root of b squared minus 4ac, take away a b, or the negative version, square root of b squared minus 4ac, take away a b. Getting a bit messy, forgive me. Oh, let me divide everything by 2a. That tells me x better be square root of b squared minus 4ac, take away b, all divided by 2a, or it's the negative version, b squared minus 4ac, take away b, all divided by 2a. There it is. And most school books write it slightly differently. They rewrite this as x is either negative b plus or minus the square root of b squared minus 4ac all over 2a. There's the way you usually see it in textbooks. But my point is, I don't have to memorize anything. If I just play this game of symmetry being my friend and try to draw a square, even if I'm doing it abstractly in an algebraic way, I'm actually doing all the algebra I'm meant to do from the standard curriculum. In fact, my students, I have them just derive the quadratic formula for themselves. Absolutely. They can do it once they really understand level 1, level 2, level 3, level 4, level 5, level 6. There it is. How to really truly own and understand mathematics. Now, I do admit, if I give you a really horrible equation, like, I don't know, that can be really nasty. Root 3x squared minus 7/3 x plus pi equals 0. I would have a horrible time doing the box method on that one. I might just want to use the formula. That's fine. There are good times where you might want to just use the formula because that would just be a battle. However, most textbook problems are very nice, and it's much more interesting to teach the thinking and the doing rather than just memorize a formula and getting answers. In fact, you saw me in the chat. I didn't know what the answers were to half the questions that you were telling me, and because the answers aren't interesting, that's secondary. Yes, you need to get answers for solving actual problems. That's fine. We'll get the answers then. But what I really love about this is teaching the thinking process. So let me stop there. That's just the algebra of quadratics. Of course, you've got graphing as well, and you've got more to do. But I really feel like my role as a teacher in mathematics is not so much teaching the content in the way most textbooks want. It's really teaching being an empowered human being. And I really mean it. There's little life lessons. If there's something in life you want, if you want a 4 and you've only got a 3, the life lesson is make it happen. And the way you do that, add 1. But there'll be consequences. If you change the left-hand side, you better change the right-hand side as well. And that applies in many arenas of mathematics and also life. Also, the other thing is I don't like hard work. I didn't want to play with fractions. So what can I do to work with, to avoid fractions? You're right. Double everything makes perfectly good sense, but that arose gave another problem. So I said, let's multiply by 4 instead. In fact, you said, let's multiply by 4 instead. Beautiful, beautiful, beautiful. I let my students say that. And we will struggle. We will not know what to do for many hours, and that's okay. but someone will come up with the idea of multiplying by 4. You guys were very quick to do that right off the bat. And in fact, that's exactly what the ancient Babylonians did. They realized that multiplying by 4 was a beautiful move. So if you go back 4,000 years, humans were very clever back then and even figured that out themselves. Multiplying by 4 was a beautiful, beautiful technique. So on that note, let me stop there. That's just a sample of how to take a piece of standard curriculum, very standard curriculum, and really make it about empowering students to be thinking citizens of the world. So if there's any questions or clarifications or comments or fears you'd like to share, I'm happy to chat about whatever is on your mind next.
Thank you very much, James. I hope our teachers saw how a very common topic that you all must be teaching in school for whatever grade level you are, for O levels and even advanced level, but how James was focusing on the thinking that goes in to the process of solving a quadratic equation. I loved when you said that answers are secondary. What you have to focus on is the understanding behind what is happening when you mechanically manipulate symbols. So I hope you all took that message. I would like to open the floor now for questions. Teachers are thanking you, James.
I've seen that. Thank you.
Yeah. Teachers, please, I would now like you to unmute your microphones and you can speak with James. You can ask any question, direct any question that you might have to him. That would be wonderful. That's what we actually want you all to do now. Anything
beautiful. Sorry. I did see a couple of questions go by because the chat's now going through very fast. Yes, I do have an email address. Now it's disappeared way up. Yes, I do have a link. I actually wrote a lot of notes about this, so you actually can read all my notes tonight. Might have been fast, so I'll keep putting the link in every now and then, but let's just disappear so fast. And then someone asked, is there a way to avoid the negative signs by making a substitution, rewrite x as negative y? Sure, if you don't like negative signs, try that. This is my answer. Absolutely do try that, and you might be able to avoid the negative side things. Though my suspicion is, if one answer is going to be positive and one answer is going to be negative, and you make the substitution, you'll still get one answer that's positive, one answer that's negative. It might be the other way around. So it might actually be unavoidable to avoid negative signs. But I love that thinking, and the answer is always try it, find out, try different examples, and explore. It's a beautiful idea. There's nothing wrong with trying stuff. The trouble is we live in a culture of exams, where exams are about being right, being correct, more or less the first time you try it, under speed and pressure. And that's not how the human brain actually thinks. And actually, I wish the exams were more questions like, what would you do in this situation? What are some good ideas that might or might not work? That would be a beautiful question, but I don't know how you assess that in an exam, because it's really more about how would you deal with this issue? That's what the skill of life is. It's not about getting answers to quadratics, because to be honest, I could just type it into my smartphone and it will be faster and quicker than me and more correct. It'll actually get the answers. I can't do arithmetic. I'm surprised I got some of the arithmetic done this morning correctly. So it's not about living in the 21st century, getting answers fast, because that's much faster than me. So it's got to be about the thinking and trying and exploring and seeing what happens. Play with mathematics.
I think I saw someone. I think I saw a couple of teachers unmuting themselves. I'm not sure whether it is to ask a question. I saw this one, Aisha, Anura. Would you like to talk and maybe ask a question from James?
Hello.
Yes.
Hello.
Kirimamuni.
Yes. Yes. Mr. Tanton, sir, may I ask a question? Mr. Poisson law is a very interesting method to quadratic equation and quadratic formula. It's too very interesting. What about you thinking?
So actually, if you look at his method, it really is the box method in disguise. He's actually doing exactly the same thing as me, as this method. So it just looks different. His middle steps are a little bit different. But I bet if you go through his approach step by step, you'll see he's actually literally completing the square in the same way. He doesn't focus on that middle term being even explicitly, though he does end up doing the same work. So yes, all good ideas manifest themselves in beautiful ways, and Po-Shen-Loh has a method that actually is this box method. It's the quadrus method. It is just the power of symmetry. You know, I tell you, if you think symmetrically, life is so much easier and so much more fun. So even Po-Shen-Loh discovered the same thing, which is fabulous. He's a very, very clever, brilliant fellow. He's a great guy.
Yeah, yes. Thank you, sir.
No worries.
Anura?
Sir, excuse me.
Yes, Anura.
Sir,
Yes. Ooh, yes.
excuse me, sir.
Anura,
That was
sorry,
hard to hear.
muted you because I think from your end there is an echo coming. Sorry,
Excellent.
Anura.
Well,
I'm sure that there are people who are having questions, but finding it difficult. I'm not sure. So,
I just. Sorry.
Shamima, you have your hand raised. Do you have? Yeah, you can speak now.
Yeah, thank you, madam. And I just wanted to say that the way Mr. James explained this was very impressive, and the scaffolding methods, the methods that we have used was very interesting. I just thank you very much. And I feel that my students will get much more fruitful lessons hereafter on this quadratic box method. Thank you, sir. Thank you very much.
You are so welcome. And of course, this raises the tension that we have as teachers, because I was as a high school teacher, did have big exams I had to prepare my students for. And my department was actually very confused, because my kids would actually answer all the quadratic equation questions by drawing these boxes on the side of the page. And no one knew what they're doing. And by and large, they're getting it right. So it really did confuse my colleagues, even though I was trying to be open about it. My students really did take this other approach and found they had success with it, even though the exam wasn't set up for them to do it this way. So that's why they're cramming all these pictures in the margins. So that gives a very interesting challenge for you, that if you're teaching, I mean, I was very much intrigued by how could I have my kids really understand and think like a human being and think like, an empowered way with agency and flexibility, and still do what the curriculum demands. So you might find yourself at odds with your colleagues. That's okay. They end up having to teach that with the colleagues, share that with the colleagues. And also, my students were very nervous about what the other classes were doing that looked different from what we were doing. That's why I had them actually derive the quadratic equation themselves, so they could see what other students were learning was actually dead to what we were doing, and they're welcome to do both ways. I have nothing against memorizing the quadratic formula if you want to, and using it. That's fine. All good, correct approaches are good and correct. Just know there's a tension here that everything is about passing exams. We say we have a culture in our classes about, teaching perseverance and teaching accepting mistakes. But really the message kids have in the end is, no, but you have to pass the exams. So it's always the exams, exam. It's just, such an awful, awful pressure. So you're going to find that balance beautifully. So I was very careful about scaffolding these problems as you described, so my students can actually see and think in a way that I care about as a mathematician, how to think through stuff, and still develop the proficiency to do what they need to do things under pressure and fast. A very hard tension, very tough tension to balance. Good luck trying to balance that for your students. And students will react because they feel like they're missing something from the standard ways. Like, just tell me the formula and get the answers. If the focus is always getting the answer, yes, memorize the quadratic formula, it'll be quicker. It will be quicker, I agree, it will be quicker. But to me, that's not the goal, even though the message of the curriculum says that's actually really the goal. So we have to respect that for our students. The pressure they're under is at odds about what math teaching really should be. Find the nice path for that. And I wish you the best of luck. It's very hard as a teacher to give students the powers to be human and also the power to deal with the system. Very tough.
AIS, do you have a question?
Yes,
Yes.
thank you for the opportunity. So first of all, I have to thank Mr. James organizing such a wonderful session. So several years experience with teaching mathematics, but the thing is some students really feel hard in quadratics. So this is such an easy method, and really thanks for introducing this for us. And especially I have to ask, in Sri Lankan education system, we have for focusing on examinations. So there is a methodology, and what we have to apply and step by step. Then when we introduce to children, I want to ask from this really from people who are in our Sri Lankan department. Then what is the possibility of getting the marks? That is, it is everything depend on marks for nowadays. So if there is any clear explanation, I will be thankful. And thank you for the opportunity.
Right, so I didn't quite hear the question at the end, but yes, that tension between exams and having students get the marks quickly under pressure is a serious one. I agree. So I would teach, this method for quadratics and all the other topics I teach in the way that I really want my students to understand the mathematics, because once they've got something to hold on to, if ever they forget a formula, they could always go back to the box method. So they might be saying, okay, for the exam, I'm going to memorize the quadratic formula and be fast that way. But then under pressure, you can forget things. So I wanted to take the time in my classes to give them another method to hold on to, which is about understanding, so that, and this is how I'd argue with them, that if you're in that moment and your mind goes blank, you can always go back to what you understand. Because if you know something, you can't unknow it. If you memorize something, you can forget it. That's the balance that we have to play with here. So yes, I would absolutely say, we are in the system. We've got to get these past the exam. Kiddos, memorize this formula, and off you go, answer those questions correctly. But we personally all care about the thinking, not the exam. However, society wants the exam. Kids understand that balance when we explain it to them and be explicit about it with them, and then we'll play the game with the exam.
I think part of her question was also to the ministry side, or maybe Shelton sir can answer that, whether if somebody follows such a method in the exam paper, whether marks would be awarded. I mean,
that's the question. That's the question. Yeah. Yes, Sheldon, what's the answer to that one?
Yeah, marks would be the same.
Yeah, so you have to understand.
But if there is a way to give more marks for the creativity in mathematics exams, that would be wonderful. World is not moving in that direction yet, Dr. James, right?
Yeah, no. And then, of course, there is a problem, because a lot of exam questions will say, solve this question by this method. In which case, if they say what the method has to be, you're stuck. You have to use that method. If they just say solve the equation and explain what you did, then there's a different approach. So, depends on the question design as well.
Peter Shanti, you have a question? Mr. Janaka, Rodrigo. Yes.
Very interesting webinar, and I would like to suggest it's better to have this kind of thing for advanced level or related to advanced level mathematics. So this kind of introduction to the quadratic equations. I would like to have kind of advanced something related to advanced level quadratic equation.
All right, so yes, I mean, obviously I started at the very beginning of the topic of quadratics today, just the very simple algebra, and then of course the next thing you do is graphing. And graphing quadratics is actually also a story of symmetry and using the power of symmetry, because if you think about the very basic graph y equals x squared, it happens to be beautifully symmetrical. And my sensibility as a mathematician says, oh, symmetry is my friend. I bet I can use that to my advantage. So I give you a very strange quadratic equation. In fact, let me show you. Let me share my screen. I've got a couple of minutes. Let me go back to showing my screen and give you a taste of quadratics for the graphing quadratics. Where's my screen? Here goes. All right. So if I've reached the point where I've know that the graph is going to be a nice symmetrical shape of some kind, then let me do something like this. Graph this thing. And I say to myself, okay, all right, symmetry is my friend. And I know it's going to be interesting in some way. And let me focus on the x values. Let me do something. I'm leading up to something that's going to be better explained if I did this very slowly. But let me look at a common factor of this. Call it a common factor of x. Let me look at that equation right now, because that tells me something really nice. that the value x equals 0 is really nice. It's going to give me y equals 3. If I put in x equals 0, I get y equals 0 plus 3. If I put in x equals -4, I also get that y is 3. Put in -4, I get that something times 0, 0 plus 3. So that tells me I've now got 2 symmetrical points on a graph I know is going to be symmetrical. Look at this. That means at 0, I have the value 3. At -4, I have the value 3. Right off the bat, I'm going to say, oh, look at this. The line of symmetry has to be halfway between 0 and -4. It must be -2. That's common sense. The trouble is, I don't know if my graph is going to be above the x-axis or on the x-axis or below the x-axis. Which one of those is going to be? And the common sense answer says, oh, well, let's just put in x equals -2. When x is -2, I see that y is going to be -2 times 2, -2 times 2 plus 3. That's -4 plus 3, that's -1. It goes just under. So I can see right now the graph of this thing has to be -4, 0, 3, and 3, and it comes down just under right there at -1. The power of symmetry. When I look for interesting x values and I know things are symmetrical, common sense tells me what to do. So even in the graphing of quadratics, that was too fast, I know, but it gives you a sense the power of thinking deeply is really advanced thinking. How advanced thinking to me in mathematics is how do you cut through all the clutter and see what's really going on and using it to your advantage. So even then, when I was using the symmetry of the U-shaped graph from y equals x squared to my advantage, I could see how to cut through the clutter of advanced graphing of quadratics. And you can do that with trigonometry and exponents and logarithms and calculus and all that sort of stuff. So all the advanced stuff you're meant to be teaching. The question is, how do I cut through the clutter and see what's really going on and then use those simple ideas to my advantage? If we could teach the world to do that in mathematics, then they could do it in anything, in any field of discipline they want to go into and be great problem solvers for the world, for the planet. That's my real hope.
Thank you very much, James. I hope our teachers could see how James is focusing on the thinking side and the exploration side of mathematics rather than just the traditional way that we all are very used to teach in our classrooms. Now, I have a lot to say, but I don't have the time. I would like to invite Dr. Shelton Pereira to formally give a vote of thanks to our speaker and the audience. So over to you.
Thank you, Gaia. Wow, James, what a wonderful and entertaining presentation. There aren't enough words to express how appreciate and how joyful our teachers are. I'm just looking at the chat. There are more than 250 thank yous and other messages appreciating what you did. It was really motivational, informative, and
Sir, sorry, sir. So you got muted. I'm sorry, sir.
what was the last word you heard, guys?
Motivational. I heard the word motivational.
It was motivational, informative, and memorable. And your flow of energy while you were teaching was, something out of this world. Yes, yes. Yeah, it shows how much you enjoy doing what you do. And the use of geometric algebra, the ancient geometric algebra to teach a quadratic formula was fascinating. Now, yes, the teachers, our teachers were really fast giving the answers to quadratic equations.
Yes, they were.
That was good. That was good, meaning we don't know what they used. No, they may have used the method that you just introduced them to. But it's a really nice thing no words to thank you. In fact, thank you for accepting for our invitation to be the first speaker of this international webinar series. We are truly honored by your presence. Okay, so you have been supporting MetaHub activities earlier too. So we certainly hope that we would have another go at not so distant future. Yes.
It would be my honor and my pleasure. Yes, absolutely. The work you're doing is spectacular and wonderful. And thank you to the work you're each doing out there. We're working with your fabulous students to actually bring that beautiful joy, that thinking, that human connection in the mathematics classrooms. It's such important work. And thank you for being such ambassadors of mathematics joy for the world, each and every one. Thank you.
So you're muted again. You're muted again.
Yes. Hope it will remain that way for the rest of the vote of thanks. And we are actually doing this in collaboration with the Ministry of Education and the Department of Science and Technology of the University of Sri Jayawardenepura, where Dr. Gaya is attached to. And I would like to thank Miss Niri and Miss Niroshi, Director, the Department of Ministry of Education, the Mathematics branch, and also Ms. Nirisha, Deputy Director of Mathematics in the Ministry of Education, for their support in getting this webinar organized. And they have been helping us in all our MetaHub activities, because we have this collaboration with them, and that is wonderful, and need to thank them for that. And I also should thank the teachers who took the message to other teachers. I mean, ministry did that, the big thing. Then also I approached some teachers and asked them to spread the message, because we wanted this to be grand, but never expected it to be this grand, you know. Yes, we are so happy. And I would I would be failing in my duty delivering this vote of thanks if I do not thank the person who made this all possible. It is our co-founder of MetaHub, Dr. Gaya Jayakodi. Yes. Yes, who is also the Sri Lankan ambassador for your global mathematics project, yes, which you have created to uplift mathematics education globally. I think you are doing such a wonderful job, James, and we would like to wish you all the very best for your work. And by the way, if you happen to visit the Southeast Asian region, James, please make sure Sri Lanka is in your itinerary.
Oh, that'd be wonderful. Absolutely. One day we'll make this happen.
Yes, try to make it happen. Try to make it happen. And
that would be a delight.
Yeah, it will be so nice for our teachers to meet you physically and enjoy what you really initiated today. It's really wonderful. All credit of organizing this, not only organizing, in fact, this is an idea conceived in Dr. Gaya's mind, and all credit should go to her. She is the person who said, let us add this item to MetaHub so that our Sri Lankan teachers would get exposed to world-renowned mathematics educators like Dr. James. So finally, we wish you all the very best, and let you sleep also, no, this night. Okay, James.
Well, thank you very much. Real honor, real delight.
Yeah, I think it's maybe 1 in the morning for James. So we should let him go as well. For the teachers, for teachers who have been dropping messages in the chat box asking for the recording, it will be available on the MetaHub YouTube channel. If you have registered in the MetaHub website, or even if you're not, you can go to YouTube and search MetaHub. We have a website there. This will be uploaded very soon. So I will not take any more time. My deepest thank you to you, James, and all the teachers who participated.
All the teachers too who
Thank you so much
Yes.
as well to Miss Niroshi and Miss Niresha. And
Yes.
you all have our teachers are
Yes.
from everyone from Sri Lanka. You have a wonderful day. James, you have a good
Yep.
night's sleep.
Thank you so much.
Catch you again.
Lovely. Lovely.
Bye-bye from Sri Lanka.
Beautiful. Thank you, Sri Lanka.
Bye,
Beautiful.
James.
All right. Until next time. Bye-bye, everyone.
James.
Yes.
Bye.